Day 451 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2044, count number of maximum bitwise OR subsets. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an integer array nums, find the maximum possible bitwise OR of a subset of nums and return the number of different non-empty subsets with the maximum bitwise OR. An array A is a subset of an array B if A can be obtained from B by deleting some, possibly zero elements of B. Two subsets are considered different if the indices of the elements chosen are different. The bitwise OR of an array A is equal to A of 0 or A of 1 or all the way up to or A of A dot length minus 1 in a zero indexed array. All right, y'all, so that may sound a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 3 and 1. The output is 2. Explanation says the maximum possible bitwise OR of a subset is 3. There are two subsets with a bitwise OR of 3. That's 3 and 3 and 1. All right, y'all, so let's break this down one step further so we can make sure we really understand what's going on here. So we have this input nums, which is 3 and 1, right? So first, 3 in binary, that's going to be, so 3 is equal to 0, 0, 1, 1 in binary. And 1 is, what is this? Oh, sorry. And 1 is equal to 0, 0, 0, 1 in binary. So when we go through this and we compare these two using the bitwise OR operator, which looks like this, that is going to be, so if there's a 1 in the comparison, then the output for that bit is going to be 1. So since there's a 1 when we compare these two, it's going to be 1 right here. Boom. So that would be, this comparison is going to be a 1. This comparison, 1 and 0, since there's a 1 in the comparison, this comparison is going to be 1 as well. So boom, because that's how this operator works. If there's a 1 in the comparison, then there's going to be a 1 in the output for that bit. So there's a 1 in these when we compare these two bits, so we put 1, and there's a 1 when we compare 1 and 0. It has a 1 in the comparison, so we put 1. Then with these, it's 0, so we could put a 0, 2 zeros right here. Then there's 2 zeros right here, so we could put another 0 right here. Now, as you can see, when we compare using the bitwise OR operator, when we compare 3 and 1, we get 3 again, right? Because this in binaries, this right here, 0, 0, 1, 1 in binary is equal to 3. So we got 3. And then similarly, if we did the same thing and we just say we compared 3 and 0, it'd be the same thing, right? It'd be 0, 0, 0, 0. So we still get 3, right? Because it's a 1 right here. So it'd be, when we compare, it'd be a 1. Then we also have a 1 in this comparison. So we put a 1 right here and then 0, 0. So both of them will be 3 when we can, and that's where we got this from. So 3, that's this comparison right here when we just comparing the 3, and then 3 and 1, that's this comparison right here. But either way, the output is still 3, right? The maximum possible bitwise OR of the subset is 3. 3 is the maximum that we can get out of these two subsets. But since there's only 2 elements, it's that's what it is, right? That's just how it's going to be for this example. So since the output is 3, the maximum is 3, and there are 2 different ways we can obtain that maximum output, we're returning 2. Now, once again, it's only 2 elements, so this was kind of a simple example. However, we just remember we're not returning the subsets themselves, we're returning the number of subsets that has the maximum value of 3. So in this case, both of these subsets have the maximum value of 3 when we compare them using the OR operator. So we're returning the count of how many subsets there are with the maximum bitwise value or bitwise OR value of these two elements, which is 3. There's two subsets that have a maximum value of 3. So that's why we return 2. We're not returning the subsets themselves. We're just returning how many subsets there are, which is 2. I'll explain a little further once we get to example 3, because example 3, as you can see, it's a little bit more in depth of an example. So now with example 2, let's look at example 2. Example 2 is pretty self-explanatory once you understand how the bitwise OR operator works. So with the bitwise, let's go through it. So in example 2, we have input nums equals an array of integers 222, output is 7. Explanation says all non-empty subsets of 222 have a bitwise OR of 2. There are 2 times 3 minus 1, which equals 7 total subsets, so our output is 7. So they got this, as you can see, when we compare. So say we took this subset, it'd be 2, 2, and 2, and we compare just 2 and 2. When we compare 2 and 2, which would be 0, 0, 1, 0, then we compare that 0, 0, 1, 0 with itself. When we use the OR, once again, we're going to get 0, 0, 1, 0, because as you can see, we have zeros here, ones here, so we have a comparison, and the ones here, so we return 1, and then we have zeros here, so it's 0. So either way, it's still 2. And since all of the elements are the same, it's going to be the same every time, right? So every time it's just going to return this subset. Now, there are 7 different subsets that we can create from these 3 elements, right? We could do these 2 2s, we could do these 2 2s, we could do this 2 and this 2, and so on and so on. And in the end, there are 7 of them. This is the formula that they use to get them. 2 to the third minus 1, which equals 7. So our output would be 7. Boom. So now let's take a look at example 3. Example 3 is going to, I think, will help explain it even further, because we have a more variety of elements that we could choose from. So let's go through it. So in example 3, we have our input nums equals an array of integers 3, 2, 1, and 5. Our output is 6. The maximum possible bitwise OR of a subset is 7. There are 6 subsets with a bitwise OR of 7. So in this example, the maximum bitwise that we can, or subset that we can create, is 7, right? So let's see how I want to show you this. I'm gonna list all the subsets for y'all, and I want y'all to go through them yourselves. You can compare them yourselves and see what happens, or what number you get after you do these comparisons, and count how many of those comparisons equal the maximum of 7, right? They list them right here. These are all of the 7 subsets that will get us a maximum bitwise OR value of 7. But I'm going to just list all of the subsets so you can see just how many subsets are in general. So this 3 could be its own subset, so we could just say 3. Then so all of these elements could be their own subset, right? So that could be 3. Then this would be 2. Then this would be 1. Then this would be 5. Boom. So those are just the first 4 subsets. Then we could do 3, 2. That's a subset. We could do 3, 1. That's a subset. We could do 3. Sorry, y'all. We could do 3, 5. That's a subset. Boom. So basically all the ones with 3s. Then we could do 2, 1. Now we could do the 2s. We could do 2, 5. Then we could do 1, 5. Sorry, y'all. We could do 1, 5. And we come underneath that. We could do 3, 2, 1. Oh, sorry, y'all. We could do 3, 2, 5. We could do 3, 1, 5. Hold on, sorry, y'all. We could do 2, 1, 5. And we could do 3, 2, 1, 5, the whole array. So 3, 2, 1, 5. So these are all of the subsets that we can create from this array, right? And they all have, when we compare them using the bitwise OR, they're all going to come up to different values. So I'm not going to go through all of that for all of these examples. I'm going to just tell you what the bitwise OR would be. So this would be 3. Sorry, y'all. Let's just, so it lines up, right? That would be 3. This would be 2. This would be 1. This would be 5. This would be 3. This would be 3 as well. Then this, oh, sorry, y'all. This would be 7, which is the maximum. This is one of the ones that we're looking for. So that's why it's right here. Then this would be 3. Sorry, then this would be 7 again. Then this would be 5. This would be 3. And these last 4 would be 7. So that'd be 7. That'd be 7. That'd be 7. And this would be 7. So when you use the bitwise OR operator on all of these subsets right here, these are the outputs you would get, right? And as you can see from these outputs, the maximum output in all of these outputs is 7. So we have 7 here, 7 here, 7 here, 7 here, 7 here. So in total, we have 6 subsets that'll get us 7. Boom. And it shows us them right here. We have the 3, 5, boom, which is right here. We have the 2, 5, which is right here. Then we have the 3, 2, 5 right here. We have the 3, 1, 5 right here. We have the 2, 1, 5 right here. And then we have the 3, 2, 1, 5 right here. So since there are 6 different subsets that we can create, remember, these are all the subsets. Out of all of these subsets, 6 of them equal 7, and 7 is the maximum out of all of the outputs that we got. So since there are 6 subsets with the maximum value of 7, that's why we return the output 6. So once again, I encourage y'all to go through these subsets yourself, just to check the math yourself, do it yourself. Use the bitwise OR and compare all of these subsets and see what you get, and then you'll see how we got these outputs from these inputs, or excuse me, got these bitwise OR maximums from these subsets. So now that we understand the question, y'all, let's get into the fun part, the actual solution, y'all. I'll make sure y'all stick around because I have 2 solutions for y'all today. Neither one of them are that long. That's why I figured I'd give y'all both of them. So the first one we're going to do is, first thing we need to do is we need to store the maximum possible bitwise OR value from all elements and nums. So we're going to create a variable for that by saying var max bit OR. We're going to set that equal to 0. Boom. Then we're going to create a helper function right here, come outside of this, and we're going to create a helper function, and this is going to be a recursive function to try all subset combinations. So for that, we're going to declare func. We're going to say is equal to max bit. That's what we're going to call it. We're going to open up the parentheses, underscore nums colon. That's going to be an array of integers. Come outside of that, we're going to say comma underscore initial val colon. That's going to be an integer. Then we're going to say comma underscore I colon. That's going to be an integer as well. Then we'll say comma underscore CNT colon. That's going to be an in out integer. Boom. So this initial val right here, that is going to be the current OR result of the chosen subset. Then I is going to be the current index of nums. And then this CNT right here is going to be the in-out counter to accumulate the number of valid subsets. So we come right here and we can open up our brackets. Boom. Now we need a base case. If we've gone through all elements, we need to stop. So we can say if I equals nums dot count, we can open up the brackets and we can just say return. Boom. Now, if including nums of I results in the max bit OR, then we're going to count it. So we're going to come right here and we're going to say if initial val of OR with the bitwise OR, so one vertical line, nums I equals max bit OR. Then, oh, sorry, y'all. This max bit OR should be outside of the function. So put this max bit OR right here. Boom. Then what we're going to do is we're going to come back right here. Sorry, this should be capital. Come back right here. We're going to open up the brackets and we're going to say CNT plus equals 1. Now, for our recursive case 1, we're going to include nums of I in the subset and move to the next index. So for that, we come right here and we're going to say is equal to max bit, open up the parentheses, nums, comma, initial val, bitwise OR, nums, square bracket, I, comma, I plus 1, comma, and CNT. Boom. Now for the recursive case 2, we're going to exclude nums of I and move to the next index. So for that, we come right here and say is equal to max bit, open up the parentheses, we're going to say nums, comma, initial val, comma, I plus 1, comma, and CNT. Now we come back up here to our main function and we are going to say declare a variable called CNT. We're going to set that equal to 0. Then we're going to compute the maximum bitwise OR value achievable by ORing all elements in nums. So we're going to say max bit OR equals nums dot reduce, open up the parentheses, 0, comma, and put the bitwise OR just like that. And once again, that's going to compute the maximum bitwise OR value for us by ORing all of the elements in nums, right? So it's going to start from 0, then it's going to come here and OR all of the elements. Boom. Then we could come underneath this, and we need to start our recursive backtracking to count the subsets matching max bit OR. So we're going to say is, we're going to call our function, our helper function, and we're going to say is equal to max bit, open up the parentheses, we're going to pass in nums, comma, 0, comma, 0, comma, CNT. Oh, sorry, it should be and CNT because it's an in-out parameter. So boom. Then we just need to return the final count of valid subsets by coming right here. All we have to do is say return CNT. Boom. So let's run it. That should be all she wrote for the first solution. So let's run it first. Okay, so let's see where we went wrong here. Oh, I think it's right here. This should be we need an underscore. So let's run it again. I mean, we need a space after the underscore. Let's run it again, and it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Look at that, y'all. 15 milliseconds beats 50% of users. Not bad, but we could get those numbers up. Let's get into the second solution and see if that time does any better. So let's get rid of this. Now, our second solution isn't that long either. It's even shorter than the first one. So let's get into it. First thing we're going to do is we're going to generate all non-empty combinations of nums from 1 to nums.count. So we're going to say nums.combinations, open up the parentheses, we're going to say of count colon 1 ... Then we come underneath this just for make it easier to read. We're going to say for each combination we need to compute the bitwise OR of all of its elements. So we're going to use this reduce again and reduce the combination using the bitwise OR. So this time we're going to say .map, open up the brackets, we're going to say $0, and then we're going to say .reduce. We're going to open up the parentheses. We'll say 0, comma, and pass in that bitwise OR right there like that. Boom. Now we need to count how many of this subset's result are equal to the maximum possible OR from the full array. So for that, we come underneath this again. We'll say .count. We're going to open up the brackets. Then we're going to open up the square brackets, and we're going to say max OR value. We'll set that equal to nums.reduce, open up the parentheses, 0, comma, bitwise OR. Come outside of the square bracket, we're going to say n, come underneath that, then we can say $0 equals max value. And that should be all she wrote, y'all. So let's give this a run. Make sure it runs properly before we submit this one. Cannot find, oh, sorry, I should say max OR value. Let's run it again. Let's see, and it's accepted. So let's go ahead and submit this and see what happens after we submit it. Let's see. Ooh, 108 milliseconds beats -% of users. I still don't know what that dash means, but it went through. It's accepted. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.